In our third and final series circuit mathematical analysis problem, we will look at a series circuit that has a 90-volt battery as well as 4 resistors wired in series, and we'll utilize our VIRP table as that is a pretty effective and efficient way to keep track of all this information. So the first thing we'll do is enter all of the information that is known to us. That would be the individual resistances of those resistors as well as the 90-volt total voltage of this circuit. We can then go ahead and realize, since this is a series circuit, we can simply add all the resistances together and get a total of 17 ohms. We now know the total voltage and the total resistance of this circuit, so we can also utilize Ohm's law to find the total current. So once we know that the total current in this circuit is 5.29, we can simply populate the rest of the current column, because in a series circuit, if 5.29 amps leaves the battery, well, that must pass through every resistor, as we only have one pathway. Once I and R are known, we can certainly multiply those two utilizing Ohm's law to get our voltages. And once V, I, and R are known, then we can utilize any combination to calculate power, either P equals IV, P equals I squared R, or P equals V squared over R, and I should wind up getting my power outputs in watts. And last but not least, I can do my self-check. I must go through R1, so that costs me 15.87. That's how much my voltage must drop by to get through R1. To get through R2, it drops by 37.03. To get through 3, it drops by 24.45. And to get through 4, it drops by 10.58. If I add up all the voltages that I must drop by going through these resistors, you will find that I drop a total of roughly 90 volts. So I spend all my voltage, I get back to the other terminal with 0, and my self-check has designated for me that I have a 99% chance of having gotten this problem correct.